Hello, welcome to another tutorial. In this video, we'll be going over the base to user script command. Base to user can be used to convert the tool's position and orientation from the base coordinate system to the user defined coordinate system. Now, in order to use this command, there are a few parameters that you should provide. Firstly, you need to provide the 6 joint angles you want the robot to achieve. Secondly, you want to provide the tool's position in X, Y, Z, as well as orientation in W, X, Y, Z. However, if your tool coordinate system that you're using is the flange center, then you can skip this part, everything in red here. Or you can simply put in 0, 0, 0 for position and 1, 0, 0, 0 for your quaternion orientation. Finally, if your reference coordinate system is a user-defined coordinate system, then you must provide some of these coordinate calibration parameters. However, if your reference coordinate system is the base coordinate system, then you don't need to provide anything here. In fact, that you should skip this everything here in green. So now let's take a look at one application of this base to user command. So here in this script example, we want to offset the tool center point based on a user coordinate system and have a robot travel to that waypoint. And how do we achieve this? Firstly, we define a few offset values. So we have dx, dy, dz, as well as drz, which is a rotation about the z-axis. Next, we want to get the tool kinematic parameters. Here we're using flange center, but if you want to use any other tools, you can simply just put the name of the tool in here. And another thing to note here is that, as I mentioned before, flange center, you technically could just have T position as 0, 0, 0 and orientation as 1, 0, 0, 0. Next, this is the waypoint. This is the initial waypoint, which we want to offset based on a user-defined coordinate system later. And so it is called VP place A. We assign it to a variable called WP. Now, when we get a global variable, when we call get global variable on a pose variable, the output is directly the 6 joint angles. Next, we call base to user. So now this is where we want to convert the base coordinate system into a user coordinate system. Here we put in the waypoint, which is WP, the 6 joint angles, and these are the tool parameters that we got from getToolKinematics. And finally, these are the coordinate parameters of our user coordinate system test. And if you want to use any other coordinate systems, you can simply put that in here too. Here, we just want to convert the orientation in quaternions into roll, pitch, yaw, just for easier access and easier alterations. So now, this is where we want to provide the offsets and modify our waypoint data. So we simply add the dx, dy, dz onto the WP position, and we also want to add the drz onto this WP RPY, the third term, which is the z-axis. And finally, we convert it back to quaternion again, the orientation. So we get back the orientation. Now, once we have altered the waypoint based on the user coordinate system, this test user coordinate system, now we want to convert this back to joint angles for our robot to travel to. How do we do this? We do this by get target pose. So we put in the position orientation, the tool position orientation, and finally reference coordinate system, which is test. And here, by using get target pose, we're able to get the final joint angles to actually reach this waypoint. And here we're just calling the 2 move joint commands, one to this modify waypoint and one to the very initial waypoint that we defined right here. So now let's take a look at what this looks like in a project. So here in this small project, basically we just have a loop and running this script file here, which we just have shown. Let's update this and start the project. As you can see here, the robot is moving between the 2 waypoints which we just have set. So again, the key takeaway here of this tutorial is the base to user command. And by using base to user, we were able to convert this waypoint into the user coordinate system. And based on this user coordinate system, we were able to apply these offsets in that user coordinate system. And finally, after we have these modified waypoints in this user coordinate system, we transformed it back into these joint angles, which can be used by our robot. And there you go. That is just a quick demo on how to use this base to user command in AUBOPE script.